Hi folks. Okay, so Wednesday, another stream. Today we'll change the strategy a bit. We'll not be solving any more random lead code problems, but we will try to use a better strategy. So here on the screen, you can see a site called leetcode.io. So probably I'll show you the URL at first. And on this side, it's provided a roadmap where we can learn in a better, a faster way data structures and algorithms. So here, once you start, we'll be traversing breadth-first search. We're using breadth-first search to traverse this tree. First, we'll start with arrays and hashes. And we do have 9 problems, 3 easy and 6 medium. So we'll be solving all of them. Actually, I do not have premium for leetcode.io, so I guess we'll skip this one. Other than that, we'll start solving one by one, and I can mark them as done here. And this will be shown, I assume, here. Okay, so that's pretty cool. Yeah, so what do we have here? Arrays and hashing, 2 pointers. We have the stack, binary search, sliding window technique, linked lists. We have trees, we have tries, we have a heap and priority queues. On the right side, we have more complex like a backtracking, graph, DP problems, I guess 2D DP problems, bit manipulation, the ones which we have finished last stream, solving a couple. So we have a little bit of understanding, and in the end we'll be doing math and geometry. Very, very nice and cool stuff. Okay, so that would be like a curriculum for me. So during the year, during different streams, I'll try my best to follow this path and solve every problems together with you using Rust language. So let me check first if the stream is working fine. Everything is up and running. It should be good. Though I didn't see it on my client. So let me try to refresh maybe. Yeah, so it's updating. Okay, so now I see it. Awesome. Some other updates and ideas what I'll be doing during other streams. Okay, sorry about that. I need to position my phone. So it looks like my phone is good. I think a very cool thing which I found, it's a framework. It's called like Loco, coming from locomotive. So it's heavily inspired by Ruby on Rails, or Rails, which is like a framework which gives you tons of possibility. It has a CLI to generate code for you, which usually I really like this type of projects. First, they're written in a very good manner. So being a new engineer, you can learn how to structure your code. You can learn different patterns to better structure your code. So as a starter, I really like this type of things. So during one of the streams, we'll try to create an app using this local. Maybe even we'll just try to do the tutorial as one stream, and during the other stream I'll try to to build an application and software as a service or something like that. I have a couple of ideas in my mind, so maybe it will be a good option to use this one. I believe it has like a very big potential. Nice, but not during this stream. Just wanted to show you. The site is called leetcode.rs, so you can follow it and see, learn about it and see does it suit you or not. Good. I guess that's it for the intro. Let's start with first problem, which will be contain duplicate, which is an easy problem, idiomatic one. Often during our work, we just need to find a duplicate or to find distinct elements. So the problem tells the following. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. There are tons of ways on how we can do this, but most of them consists of storing the already visited items. And the simplest, I guess not the simplest, but as a pattern, you can use a hash set. So one way to check if this is a distinct array or not, we can do the conversion of these nums into a set. Automatically a set will be distinct because we can store only distinct elements into a set. And we can compare the lengths of initial nums vector and then the resulting set and see if they're equal, then we have distinct elements, and return false if every element is distinct. Okay, and actually it's vice versa. So let's code this. Distinct elements. I guess initially I'll need the len. So I'll have like nums len. Then, because I'll be moving or consuming this vector, and I'll not be able later on. Okay, so it will be like into iter, and let's collect. We'll be collecting a hash set of I32. I have a typo, elements. So now we need to be attentive what's requested from us. So return true if any value appears at least twice. So actually what we'll need to check, it's len not equal to distinct elements len. So this will not compile because we'll need to include hash set. So let's add it. std collections hash set, and now we should be good. Indeed, all the tests are green, and let's submit. So this is one way on how we can solve it. Less work to do. But as we can see here, it's not necessarily the fastest way. So we are actually, if that will be a bell curve, we are on the right side, which is not necessarily a good thing. So maybe a faster algorithm will be is to still have a hash set, or in our case, we actually don't need a hash set. We may use like a bucket where we'll be incrementing the count. So first let's check. So description, yeah, it's actually L10 power 5, so 10,000 items. Yeah, I guess still the hash set will be better suited. So we'll have the hash set, though we'll not collect everything, because maybe we'll not need every time to collect all the data and compare it. So it's asked from us, return true if any value appears at least twice. So the first time we found a value which appears twice, we can return true. So in this case, let's refactor this to make it faster. We'll not need this part anymore, but we can create another idiomatic name variable called scene, or visited. That's also a possibility. Scene, I do prefer scene for this specific case. And now let's go with each item in our nums. We do a check if scene contains item, then we can return true, else we'll be returning false. So, and yeah, we'll need as well to scene, we need to insert it if it's not found. This is classical way to write this code. Okay, so yeah, we'll need to make it mutable. My mistake. This also works. And if I try now to run it, we should get better results. We should, but we did not. So this means there are faster solutions. Maybe that will be a good opportunity to learn something. Oh. Oh. Yeah. So here, as you can see, it's exactly our algorithm. We still have this for loop, contains, insert, return false, return true. We do have a bit more spaces, but there is a hugely important trick. To not generate like a dynamically sized hash set which grows, we can just and here it's a little bit better, because if it's done in one go. So this is this optimization for memory, and this is this optimization for not checking, to not check and then insert. So it's done in one go. If we insert and return true, yeah, so we'll optimize it, insert, and then we'll return false in the other cases. So yeah, with capacity, we can do the same things, nums_len. So pretty cool optimizations. Oh, sorry, it's not a reference, but we'll need the value. Okay, so let's try now. With this optimization, we should get better result, but not the fastest, and that's interesting. So what did we mess up? Because it's literally the same code. I don't know. I mean, maybe at that time that was the result, but now it's this the result. So yeah, we can see everyone doing exactly the same thing but having different results. Anyway, both cases are fine. Time complexity of the algorithm will be O of n. Space complexity, worst case, will be O of n as well, because we will need to store all values in our hash set. So all of those algorithms here, they have the same time and space complexity. Though with micro optimization, you can gain a couple of microseconds. So cool tricks here and there. Okay, I guess we are done with this problem. So we can mark this one as done. Let's go next one, valid anagram. So what do we have here? Given two strings s and t, return true if t is an anagram of s and false otherwise. Okay, so what's an anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Okay. So if it's a boolean, again, in this case, we'll just need to count letters for A and B, and then compare the results. If the results are exactly the same, then we have an anagram. Let me check again. So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So we'll need to have exactly the same number of letters. Okay, I guess we'll need to hash maps, but I'll not necessarily use a hash map for this, because by looking at the constraints, S and T consists of lowercase English letters of alphabet, so we know the English alphabet has 26 letters. So we will just create a vector, 26 position, and for A will be at index 0, B at index 1, and so on till the Z will be index 26 or 25 if you count starting 0. Okay, good. So let's create a small helper function, like a counter. Maybe we can call it counter, or just count letters. So we'll be providing our string, and we'll returning back a vec of usize. So as bytes, we can do fold. We'll be providing our vec, which starts at 0 and then 26. We'll have a mutable accumulator, and our ch, our character, as a byte. So I'll need to remember, because I don't actually remember what's A in binary form. But do I need to? Because I don't think I need to. What I can do like let index will be like ch. We know this is a byte. Maybe I should call it like a byte. Okay, so we have our byte. It's either 97, 96, or I don't know which one exactly, but I can provide A as U8, I think. I think that's the structure. So if it's an A, this will be 0 in all cases. So we'll have like accumulator of index plus equal 1. And we'll need to return our accumulator. And we'll need to return the whole vector of usize. So this will be our counting letters algorithm. And now the next stage, what we'll need to do is checking if our algorithm, if our counters are good. So how can we do that? No, first let's have them. So to be like s let s count will be self dot count letters, and then we'll be providing s, and then we'll have like t count self count letters, and we'll be providing t. So now we can zip them. We know they will be equal size. So a way to do that, it's like s count dot iterator dot zip, and then we'll be doing t count dot iterator, and we'll need to make sure that all of them are equal. So we have a and b, and we'll need to make sure that a is equal to b. Okay, I guess that should do the trick. Let's run it and see if this works. It's not an iterator. Okay, so as bytes, we'll need to run as an iterator, and maybe we'll need to play a bit with the references by an U8. Okay, I guess, yeah, we'll need to cast it as a new size. Cool. Yeah, so we do have our tests. Everything seems to work just fine. This part, maybe it's a bit more complex, a bit harder to understand, but it's a very cool feature of Rust, because we have two iterators and we can zip them together, and the next like function, which will be another like a functional approach, will provide us a tuple of a value from the first iterator and the b, a value from the second iterator, and then we can do different operations. So what I'm doing here, I just make sure that both counters are equal. Okay, cool. Let's submit and see if this works, and let's move on. Yeah, it does work, and we have a pretty fast solution. Though let's check what's the fastest. Exactly same same solution. Oh, this one is even cooler, because hash maps, they have the option to use the equal sign, which is really cool. So if I had used here a hash map instead of this, I wouldn't need to write this part. But yeah, it's kind of a trade-off, because hash map will take a bit more memory. So I'm pretty sure I win on the memory. Wait, so yeah, get num count, yeah. 0 to 56, actually it's 26 only. So you don't need that much, but it's... oh, okay. Yeah. Oh, that's even cooler. Actually, you can do that. Okay, so you don't need to do that. Oh my god, I'm stupid. So I just wrote more code than needed. So let me check if this works. Yeah, it does work. So I don't need to compare. Probably inside, it's exactly the code which I've written, or same approach. But I don't need to do this extra work, so that would be faster. And I think we can improve a bit, and this will be a little bit faster approach. Cool. We solved another one. Let's mark it as done. Move on to sums. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. Okay, so given an array of integer nums and an integer target, return indices of the two numbers such that they add up to target. Okay, I remember this problem. Actually, it's a pretty cool problem, and first time I saw it was during a Google interview. So Google, they presented their way on doing interviews, and they gave this problem to a senior engineer, and he came up to different solutions, some of them being pretty cool. But you need to know, in this case, a very important concept. The concept is called like I forgot the name. It's complement. What does the complement mean? So yeah, I guess it's time for us to move to our whiteboard. Let me copy this input. So we do have, but I need a minute. I need to check something. Okay, so everything good. Everything good. So yeah, we'll need to know the complement concept, because we have our target and we have different values. So like 2, 7, 11, 15, and so on. So the trick here is to do a set. So we'll be traversing once our array, and we'll be setting the complement into a set. So we'll having like a set. How we'll be computing the set values. So assuming we start with 2 in this case, yeah. In our set, we'll insert 9 minus 2, or we'll insert 7. For 7, we'll insert 2, because we have like 9 minus 7. So we have a complement, or a set of complements where we'll be storing all of our complements. So for 11, what will be like 9 minus 11? That will be like minus 2. And for 15, it will be like minus 6. So this will be our set of complements. And how we can use that? So assuming we traverse now our value, so we have like value 2. Now we'll need to check, do we have a value in our complement set? Like 9 minus 2, 7. Yes, we do. This means we can fastly identify where's the position of 7 and so on. But yeah, with the position it's a little bit trickier, because we'll need to provide the output. So for the first value 0, I do have the position because I know it. But for 7, we'll need to store it, because if we store only the complement part, then we'll need to do a traversal and find at which position is this 7. Maybe there is a way on how we can smartly do that. Yeah, let me think. How can we smartly store position of the complements? I guess the simplest way is to have another structure So it will be like a hash map. So for 2, we'll have position index 0. For 7, we'll have position 1. For 11, we'll have position 2. And for 15, we'll have position 3. So we can have this structure. We'll use extra memory though. But once we have like the complement hash set and the hash map with the indexes, we can solve this problem linearly and pretty fast. We don't need to do any combination. So time complexity of the algorithm will be like a big O of n, because we'll need to create a complement set. We'll need to create this set from those values, from those indexes. So we traverse nums. Actually, we'll be traversing it. Yeah, we may do like index and position once. No, actually, we'll need to do it 2 times, but that doesn't matter. So 2n or x multiplied by n still will be linear. Though with memory it's a little bit more annoying, because we'll be using like 3 times n. This means we'll have like yeah, actually 2 times, because we'll have one hash map and one hash set. So we'll have like 2 new data structure, which will use the same space as n. So yeah, actually it still will be big O of n, but would have been nicer to not use anything extra. So we'll have a fast algorithm, but not necessarily very good on memory. Okay, so let's think differently. Maybe there is another way on solving this problem in linear time. I don't think it's possible to do it not in linear time, but maybe there is something smarter to reuse the given memory or something, or to use a constant or something. I do not see it, to be honest. I do not see it. Yeah, so comparing with the brute force solution, like doing combination of 2, 2, 7, yeah, in this case it would have been fast, but I'll need to do like 2, 7, 2, 11, 2, 15, then 7, 2, I guess doesn't matter. 7, 11, 7, 15, then 11, 15. So close to n square, because it will need like 2 for loops for that. So a brute force would have been like a big O of n square, but now we got it to big O of n, so which is a pretty good improvement overall. Yeah, let's code it. Let's code this one. So let's do the complements. Let me double complements, which will be a hash set with capacity. Yeah, that would have, we learned this trick last time, and we can do like nums length. So we'll have this part, and then we'll need an index map, and this will be like a hash map. So in our case, it will be a hash map new. Let's use this to collection. So we'll use like hash map and hash set. Now let's traverse first time our vector. So we'll have like 4. I'll need the index and the element. And let's do nums iterator enumerate for the index part, and then we'll do complements.insert, and we'll do target minus lm. So that would be the complements part. But wait a second. Do we actually need to traverse it multiple times? Because maybe I don't need to traverse it multiple times. Let's try to, yeah, let me remove a bit. I don't need the hash map with the indexes. Because let's assume we just start traversing it once. Still we'll use our set. But at first it will be like kind of empty. And let's go here. So we start with 2. We have seen 2. What does it mean? This means we write the complement 7 in our set. But actually, yeah, still the trouble with the index, because I'll not know what would be the index. I still will need to know the index of 2. So yeah, probably probably we can do it in one go. I mean, traverse it only once, though I'll still need to recall the index. Because my idea was, okay, so I have 7 in my set. Then I'm moving to this second element, 7. I check, do I have 7 in my set? Yes, I do. This means if I do have 7 in my set, this means there is a complement before seen, which in pair form out my 9. And what will be that complement? It will be like 2, because I can do find a complement, 9 minus 7 being 2 in this case, and then I'll need to provide the 2 indexes, like 0 and 1. 1 I know because I am at this point, but previously I do not know. I need to find the index of 2. So I may go backwards till I find it because I know it's backwards, or I can check it in a hash map. Oh, hello, Night Emperor. So welcome back. Long time no see. I guess long time I did not do streams, so maybe that's the reason. Okay. So we do have this part, but first, what I can do, I can check. Okay, so let the complement will be target minus lm. So let me check if it does exist in my set. If complements contains complement, if it's there, this means we found out a pair. And what would be the pair? It will be like current item, and we'll need to find the other one, and the other one we'll need to find it in our hash. Do you know 2-pointer approach? Pointer. I guess a way is to not sure if that's exactly the thing, but let's assume we start here at 2 and then moving this on the right side if it's complement or not. So here having an I and here having a J, something like this. And we do compare them. If it's not correct, then we move J on the right side, then stuff like this. So I'm not sure if that's the case. 2-pointer. for this problem, because I'm doing a little bit different. I'm doing with the complements. Maybe it's a bit more complex though, but still it's a big O of n, so it's pretty fast. Yeah. Yeah, I mean, I guess two pointers or a sliding window, also called it's a similar approach. But how can this help me? I don't really know. Because okay, so yeah, let's try to simulate a couple of examples with okay, so we have like 2, 7, 11, and 15, and let's have like I being here and J being here. So we do sum and it's 17, but we need to know the assumption that they are sorted, I guess, because we'll need to sort them for this to work. Is it written somewhere that they are sorted? Because I'm not sure. No, it's not mentioned that they are sorted. So if it's sorted, I can write such an algorithm. Like I see 17, and the sum is bigger than my target, like 9. So pretty sure we'll need to move J. So we do 2, 7. It's 13, and then it's not good as well. So we'll move J on the other side, and then I have like 9 equal 9. So I find my solution. But this implies that this 2 needs to be that the vector needs to be sorted. So my algorithm, because if I sort it, this becomes trivial. I mean, pretty easy, yeah, indeed. But if they are not sorted, then this will not work, because I do not know when my items grow or shrink, when to move pointers. Does it make sense, Knight Emperor? Or I have a flaw somewhere in my reasoning? So if we sort, we'll have like a big O of n log n, which is unfortunately worse, or actually it's bigger than big O of n. So I'll stick for now with my hash set and hash map approach. Okay, so we do have this part. We have the complement. If it contains, yeah, this means we found a pair. We found a pair. Oh, so what's the start? Or this would be like the end of the pair. But we need to find the start. How to find the start? We'll have like let start will be like target minus complement. Oh, fan. Yeah, not sure I know how to do it in big O fan. If it's not sorted. Yeah, probably there is a way to do that. But I don't know it. So imagine like we have 3, then 2, then 9, then 15, and the target it's yeah, let's put somewhere 7, and the target it's 9. So we have 2 pointer I and J. Yeah, we do sum because we need to do this sum. So first we do this. It's 18. What does 18 tell me? Do I need to increase I or do I need to increase J? or decrease j. Maybe I need to decrease j, but if the order is not assured, like it's not sorted, I don't know. So it does work on big O of n, that's correct, but we need the precondition for this to be sorted. If it's not written anywhere that this is sorted, then I do not see how we can do with 2 pointers. Because first we'll do the sorting and then we'll run this. Yeah. So yeah, we do have 18. I guess here, what to do? It's bigger than 9. So decrease j. Yeah, we may try to decrease. No, I don't know. I do not see it working. Yeah, let me try to write this to finish this, I guess. Do you know time complexity well? If yes, then can you explain me? I've been weak in this. Oh, okay. What does time complexity mean? I guess it's a lot of math there. But to simplify it in a more practical way, you'll use there are many ways. There are big O, there is theta, there is a lot of different notation, and there are like function which asymptotically they grow. So, but this is like a lot of useless complex theory. So a simplified way for you to think, so we'll use this notation big O of, and then the algorithm in itself will do, let's say, a simple algorithm like sorting. There are multiple ways, multiple sorting algorithms, but one way, like a simplest bubble sort, you'll need like 2 for loops. So for I and then for j, and then inside you'll do the comparison. If I is less than j, then you swap the values. So this will be like a bubble sort. So what will be the complexity of this? If you have one for loop which iterates over all elements, that would be n. If you have inside another for loop, this will be like n multiplied by n, because you have a nested loop. So in this case, for a bubble sort, it will be like n square, the sorting part. Big O. So this is called time complexity. So when you look through a code and you see a for loop, and inside another for loop, automatically you may think, it may not be the case, but like 99% of the time, you may think that this will be, the complexity of this algorithm will be like n square. Though there are smarter algorithms than bubble sort, so like quick sort, merge sort. So quick sort will have a notation of big O of n log n, because it does it uses a divide and conquer approach, which pretty much divides the array in chunks by 2, using a pivot and putting the elements there. So it's a little bit faster. Actually, it's way faster if you draw this 2 function, and you'll see how they grow. So n square grows exponentially, not actually exponentially, but it grows faster than n log n. So if you draw a graph in the form of numbers, so imagine here you have 0 numbers, and here like 10 million numbers or 100 million numbers. So n square will be something like bam, but n log n will be something like, actually it's still lower, but it'll be something like this. Oh, but most of the time you don't need to know how to calculate that, because you'll need to remember. If you have sorting, it's n log n. Yeah, so it's like a cheat sheet. If you have a couple for loops, it's n square. If you traverse just once the array, it will be like only n, or linear. So you have like a couple of structures which you'll need to remember concerning complexities. So it's O of 1. This is called like constant time. And operation like 1 plus 2 or a plus b, if you have a couple of variables, the result of those operations, it's called constant. So it's constant time. The next one will be, I recall, it will be logarithmic. So log, usually it's when you have like a divide and conquer. So you have, let's assume an array, you divide it then in two. The next iteration, this division, it's n2 and then again by 2. So it's like a binary search, a couple of algorithms, and this is called logarithmic. Next one will be big O of n. This is called linear complexity. So linear algorithms is every time when we traverse a vector, so imagine a for loop for each item in the vec of vec, do x, y, z, linear. Next complexities, it will be like a big O of n square when we have two for loops. Then you have different combination of, and this will be, what's the name of, I guess it's n square. I don't know. So you have like exponential algorithms like 2e. This will be like exponential. So you kind of need to recall this terminology. And there is also a theorem called master theorem, where you'll need to learn how to solve recursions. And using that master theorem, you can find faster the complexity of the algorithm. It's squared. Yeah, I guess it's squared. Yeah, exactly. So that would be enough from practical standpoint to understand what are you talking about in algorithms, and understand if your algorithm is fast or not fast. So this comes in this order. This one fastest, like constant time best, logarithmic it's better, linear a little bit it's good, squared slower, and slower polynomial. Yeah, I've heard this word, but I'm not sure. Not sure what does it exactly mean. So you need to practice a bit on how to write this code. So we can do using this example on what will be the time and space complexity. Because you have like time complexity, it's one variable, but the second will be space complexity. Polynomial. Yeah, let's check. Polynomial time complexity. Yeah, it's somewhat what I've written here. So big O of 1, constant time, log n, n log n. Yeah, actually it's n log n squared, 2n, and n factorial. So exponential ones. polynomy. I don't even, I can't pronounce it. Yeah, so as a rule of thumb, if your algorithm goes beyond n square, I heavily suggest to optimize it. So you pretty much never write an n factorial algorithm, because this doesn't make any sense, and simply enough it will never finish for you. But yeah, that would be like the cheat sheet operation. So when you try to code or solve problems, it's either big O of n, maybe n log n. Worst case scenario, it will be n square. You don't go beyond that. It's not a solution anymore. So yeah, kind of that's the trick. Okay, so let me try to to finish this problem. Okay, so we have the starting point. Now we'll need the starting position. So how we can find the position? We will have our index map, and we'll get the start. So let's do a start position, and here first thing we do like index map that insert key will be lm. And the value will be index. So we'll have our position, and here vec I32 will need to return, because we know we found our solution. We need to return the start position and current position, which will be a index. But I guess both of them will need to cast as I32. Yeah. Usually that's the way to go. Yeah, more experienced engineers tend to go to optimized or better approach right away, because they know that brute force it's too slow. But as a starting point, if you do not know how to code it, you just do the brute force. And then the interviewer may help you suggest use hashing, use a different data structure, and optimize it. So as a trade-off in engineering, usually it's quite simple. So most of the time you do a trade of space to get time. So that's actually, and vice versa. So you trade time to get space, and you trade space to get time. So you have two variables. So time and space. So it's like, you know, that balance weight systems. You kind of, if you want to grow time, I mean, if you want to reduce space, in interview or write direct, okay. Not sure I got. So in interview I write direct log to create hardware, no any kind of complexity, one clock time, one response, go hard. Yeah, it depends. It really depends on many things. Yeah, so but overall, how I do understand engineering like software engineering. It's balancing these two things. So that would be my philosophy of what engineering at its core is. Time and space. By space, I mean memory, RAM, HDD. You have like mem part, RAM, HDD, blah blah blah, and time, it's CPU. So if you want to increase this, faster times, you'll need to trade this. If you want space, then you'll need to trade the CPU. It's not possible to have nothing out of everything. So yeah, some algorithms are at the basis, but for us as software engineers, most of the time we just balance this two. Yeah, time and space is relative. Exactly. For sure. Yeah, by the way, welcome, Unwarekar. Welcome. So you're coming to all streams. So you'll have the highest mark during the session. Yeah, I have like, I don't recall how much time, like 20 to 30 minutes where I play to okay, let me use this where I try to solve this one, and I guess we should be done. I just need to panic here that unreachable code for this to compile. So yeah, let's check. Probably it will not build right away because I may have troubles with this. Yeah. Start. Okay, so start needs to be a reference. I agree. Cannot find value complement. Why can you complement? So it's there. How can? Oh, I have a typo. Yeah, okay, so got it. Yay. And here, start position. Start position. Okay, so start position will be an option of view size. Yeah, kind of. I'll need to unwrap. Yeah, let's me unwrap it because I know it will be there. The nature of the algorithm will be there. Yeah, and we will need to dereference that. Okay, so what else? Type annotation, need for hash set. Okay, so it doesn't know what's the type of this. Okay, let me create a type. Hash set of what's the complements of I32s. And we do have runtime error. Okay. Guess time to move this code. Okay, so I think it's the end of programming. We will write in even higher level languages, or maybe we will just think about the algorithm, how it will work. Yeah, I kind of see this in the future, but we are not at all at that stage. So maybe in 5, maybe 10 years from now on, it will be something like that. But usually with like more sophisticated tools, we just build more sophisticated programs. So simple sites, like simple applications, simple things, for sure AI will handle. So you'll not even need to write a single line of code. But imagine how our world works and how competitive advantage works. If every company can build their software extremely fast using an AI, they will not have any competitive advantage. So they will strive, they will search something, they will think of building something even stronger to have advantage over their competition. So this is like the driver of madness, let me call it, of capitalism. So yeah, we'll have like better tools, but the software will become even more complex, and we as engineers will need to develop a bit different skill sets. So that's my opinion. So I'm not afraid that I'll lose my job yet, but I'm pretty sure, and I'm afraid that with the better tools, my job will become even more complex. Imagine like 10 years ago, there was no position like front end or back end, cloud engineers or DevOps. It was just engineers, so no all this branching and stuff. So in the future, we'll have like another layer of 100 other branches. It will be like a AI data scientist, front end oriented engineer, or something like that. I see this coming for sure. Okay, yeah, let me copy this. So two sums, cargo, new, two sums, and we'll need to do it as a lib code, two sums. Let me do this, zoom it a bit for you guys, copy my code and try to run it here and see what's the trouble. So we have this here, and let's add a couple of scenarios. We have like a tuple, 2, 7, 11, and 15. Yeah, probably I'll need here the target, and I'll need to provide back a vector of 0 and 1. Yeah, and I'll need to disable copilot. So here I have my nums target. Here I have like solution to sum, nums and target. So we do have our tests, and what's the trick here? Unreachable code. So we did get to unreachable code because we do not write the complements, I think. Yeah, we do not write them. Complements, insert, complement. I guess that should do it. As well, unreachable code. Why? Yeah, let's check again. So we have our complement. We insert our map. We check the complement. Wait a second. No, actually we should not check this. We should check the element. Yeah, we should check the element. That's the trick here. So it's 1-1. How is it 1-1? Index. So start position, start target minus complement. No, target minus element. Yeah. Okay, so we had a couple of bugs, but we managed to solve them. Yeah, let's, I'm interested to see what Clippy has to tell about my code. Oh, image trained a neural network for special hardware. You just write problem and hardware instruction set and you have working product. Few second OPR, no meetings, no nothing. All programming language will die, especially JS. I can see that coming, but as I've told, it's not yet there. Simple stuff, yeah, for sure, like small apps, to-do lists and stuff, yeah. But once you have like millions lines of code, like applications interacting with each other, I do not see it working efficiently. So it may do a simple website. I think it's pretty easy. A simple application, yeah. But to interact with hundreds of them, like what we have now at work, we have like 400 to 500 lambdas interacting with each other, EC2 instances. So like millions of lines of code in different languages even. So it's not trivial. And we humans and our brain, it learns way faster than any AI and understands stuff. But it's a helpful thing. AI, it helps solving. Yeah, these kind of problems, they will solve like peanuts. It will not be a problem at all for an AI. Because it's pretty straightforward, and it was trained with millions, I guess, of problems like this solved. But more complex stuff, I don't know. I use Copilot at work, and sometimes good things, other times pretty weird solutions. Not even weird, but unoptimal. Could be rewritten in a way smarter way. Okay, so this works. What I want to check, it's Clippy. But I'm not sure where my terminal disappeared. Okay, so terminal, get me please. Okay, cargo Clippy. So yeah, I changed this to LM. Yeah, let's do some changes. We don't need this. We found the pair. What else? And that's it. Only this. That's a little bit. But the GS will die. No. I mean, I hope. Because that's not a necessarily a good language. But at work, I do write in JS myself. So it's comparing to Rust, GS, it's garbage, complete garbage. But it has its own pluses at the same time. The amount of productive things you can do using TypeScript and having like a rule of common sense base rules to not use weirdly JavaScript, you can iterate very fast and with pretty good performance. So I would not discard JavaScript necessarily. With TypeScript, it's decent. Okay, so we have some wrong answers. Case free. So it's free, and then it's the target. Oh, oh my god. Oh my god. Oh my god. That's tricky. And I guess for this specific case, I can change the order and put it here. Because if you have duplicates, my algorithm will not work. Actually, it will, but the trick here, what I'm doing, it's I'll do my complement session and then I'll try to find the positions. I guess this should work. No? Yeah, it did work now. Yeah, because I'll need the first index to be there, not the second. Okay, so actually we finished the algorithm. It's not necessarily simple nor complicated at the same time. So we use two data structures, helpers, a index map and a complement hash set. So first we find the complement. We check if it's already in our set. This means we found our start element, and then we'll get the start element position. We know it's we'll already traverse it, so we should find. And then we return the result, and here we insert the complement in our data sets, and we insert the indexes. So what else do we have? So this is done with the map contains key complement. Oh, this is even cooler, you know? But it's the same approach. You see, it's same approach, but I do not understand here how do they manage the indexes. Map get complement. So what do we insert in the map? Indexes. Okay, so we insert in the map the indexes. Okay. Map contains key. Oh, yeah. Oh my god. Okay, so I guess I overcomplicated with the complement set. Because we don't actually need to store it. We just need to store the index part, and that's it. Yeah, this is way smarter. I overcomplicated with this part. We don't need it. We don't need a complement hash set. It's this index map enough for us. Because we check the key, but in this case we'll need to rewrite it a bit. So yeah, we don't need to insert the complements, but overall not necessarily bad things. So yeah, we are on the leaderboard, so third place. How it works? Sorry, what exactly how it works? How it works what? The solution which I saw, the leader one, this one. Okay, yeah, I guess we'll see. Anyway, yeah, I don't need at all the compliments. Index map was enough to solve everything. But anyway, we solved it and we move on. So we are 3 out of 9. And we go to medium. Do I have more time? But I guess we'll start next session with group anagrams. Let's read it first, I guess, to have an understanding on what the problem is about. Yeah, I mean, it's concerning AI and the future of this. Oh, I didn't want to do this. Group anagrams. The future of AI is uncertain. Oh, I solved this one. Oh, I recall. I solved this problem. So actually, we don't need to solve it again. It was solved. I don't recall when exactly. But it was during as a problem of the day. So I solved this one. I guess similar approach. We find the hashing part, and we collect the values, and should be it. So yeah, let's mark this one as done as well because it's solved already. So let's move to this one. Yeah, to get back to my thought on how AI will impact. I do not see this as a threat, but more as tools which you will need to adapt on using. I recall when I started programming, there was like a lot of resistance from people to use a normal editor. Now we use VS Code or IntelliJ or any other normal professional tool. I recall senior guys, they were writing in Notepad, like literally a text editor with nothing else, no indentation and anything like that. So yeah, we have now way cooler tools, AI, which will need to learn how to use it properly. And imagine how complex will be the new systems which we'll be building, because a lot of stuff which was difficult previously, now AI make it easy. This means the systems will become even more complex, so no easy stuff for the future. So that's my opinion. Okay, so top K frequent elements. Okay. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Yeah, this one it's quite trivial as well. Pretty simple. If we go to our drawing board, so imagine we'll have a dictionary where we'll count occurrences. So 1, for example, 3 times, 2, 2 times, 3, 1 time, 4, 0 times. Actually, 0 cannot be because we cannot count it. But let's say 5 would be like 6 times, and so on. So once we do this, next stage we'll need to sort by occurrence. So we'll need to sort and then take k items. So if we're talking about time and space complexity, time complexity first. Sorting, where let's say counting first will be n. plus sorting will be like n log n, which will be resulting into n log n, big O of n log n. Can we do better? I mean, that would be like a pretty decent approach, good result. But can we do better? Can we do it in linear time? That's the question. I guess to not sort it somehow, to remove this. If we get rid of the sorting part, we'll remain only with the traversal. So can we do differently? I do not see it yet. I do not see it. I do not see the solution. So probably we'll just code it with answer is unique. Oh, that's cool. Your algorithm's time complexity must be better than big O of n log n, where n is the array size. So it should be better. Yeah, that's challenging. Oh, yeah. I'll think on ways on how we can do that. Some smart data structure. I'm thinking of heap kind of structure to store the accounts, or what else? Well, it's maybe it's oh my god, I forgot the name. We were solving a couple of problems during day. It's called a stack, some sort of pre-ordered, not order stack. Yeah, I forgot. I guess it's pre-ordered stack or something. Key will serve as a counter. Yeah, but I don't want to sort them. I just want to but yeah, I mean, yeah, you're right. You're right. Key will be used as a counter. Man, how it's called that stuff? Order stack? I forgot the name. Yeah, let's check. Maybe there is topics. Okay, heap priority queue, sorting, divide and conquer, bucket sort, counting, quick select, hash table. Let me check again. So if we go here, so that would be the values, and this will be the count part. in our hash map, but we need to return back. What do we need to return back? 1 and 2. We need to return the values, not the count. So we need to store so key and value. Yeah, I mean that's the idea, though. How can we? Probably I'll need. Man, I forgot the name of the data structure. But the idea, let's assume we have the following vector. So let's go with let's go with a simple example. Let's go with I guess let me copy this example. It's 1, 1, 2, 2, and 3. Okay, so that's good enough. So we have like 1, 1, 1, 2, 2, and 3. So we'll need to traverse it only once. So that's a constraint for us. PlayStation. I may switch it if you don't like. I have like 7 or 8 songs, like lo-fi, down tempo stuff, which I tend to use. Okay, so we kind of need to show the most k frequent, so k being 2 in this case. So let's assume we start counting. Maybe I'll just create a vec of size k. Yeah, because we'll need 2 items. Yeah, let me check the constraints first. So how many 10,000, and the value is from minus 10,000 to 10,000. Nah, not sure. Okay, so let's assume we go simple. First stage still will need to count. So let's assume we'll have 1 being 3 counts, 2 times we saw, and 3 being 1. The question now is we need to pick only the biggest 2 without sorting. Or there is another option, to use a smarter sort, like not an n log n sort, like a quick sort or something, but to use something like bucket sort. Bucket sort will mean we'll need to have for all values starting like minus 10 power 4 to 10 power 4 a value of a counter. But anyway, so no, that doesn't make any sense. So we'll need to I think I got it. Okay, so we will store in reverse order the bucket sort. Okay, so I got it. So we will have we know that's 10,000 elements. the index of the elements will be the count. Yeah, I think when I got it, that's your idea, but I didn't get it at first. So we'll have like 10,000 items. Yeah, something like this. And we'll have here something like 3 for value 1. I guess 1, 2, 3. So this will be like 1. But what happens if we have 2 having the same value? That's a little bit tricky. Now I'm thinking we may have like 2 numbers here in the same value. Okay, then it will be like a vec. It will be a vec of items, not necessarily just an item, but a vec of items. And I go from reverse order where it's not. Okay, so we may have like a empty vec or none. Okay, so either it's an empty vec or it's a value. So I'll need to get everything, but here also I'll need to count how many. So I'll need to flatten, deflatten, then take 2. Okay, I have an idea how to solve it. I'm not sure if I have the right mindset to explain, but we'll be using a bucket sort. So first stage, we'll count how many items. So this will be like big O of n. We'll need to count them, but we'll be counting. Actually, not counting, but we'll be putting the result of this hash map into a vector. The index of the vector will be the count of the items, but the value will be the items themselves. But we may have the problem like we have 1 being 3 times, and let's assume 4 as well having being used 3 times. And in this case, in this position, I want to have like both 1 and 4, not only 1 or only 4. Linked list. Yeah, I mean, we can do linked list, but I don't see the reason to do linked list. I'll just use a vec. But let me check the constraints. Maybe they want the number of unique elements in the array. So answer is unique. Nums and integer k. Okay, so we may have duplicates though. So I may have like let's assume I have another 2 here, and I'll have troubles because I'll need to still the answer will be like 1 and 2 or 2 and 1. It depends on how we write them. But yeah, okay. Yeah, let's try to code this one. Okay, so not here. I guess let me create another top k frequent elements. I like this one. It's a pretty cool problem. So cargo new lib top k frequent elements code. Yeah, let me set up first the stage. It will be pretty fast coding because I have in my mind, and I think I explained overall the idea behind it. We may have some troubles with the implementation, but I'm confident. Okay, so we do have this part here. Let's add scenarios. So first we do have a tuple. So have a vec and a number 2, and we return a vec. So we have nums k. So be like nums k, and here we'll do solution. It's okay. Okay, so copy this. Paste it here, and here we do 1 and 2. So we have our scenario. First stage, do the dictionary part, do the counting. Let dictionary, I'll have like nums dot iterator dot fold hash map new mutable accumulator item. So let entry will be accumulator.entry item or insert 0 entry plus equal 1 and return accumulator. This needs to be like that. So we'll have the dictionary or the counting part. Counting part should be that. Second stage, we will need to create our bucket sort. But we'll need to create our bucket sort in a pretty interesting way. Because we'll do dictionary. Yeah, first let's create our bucket. Bucket. Mutable, it will be a vec. At first everything it's 0. Or actually not 0, but it will be a vec, an empty vec. And we'll have 10,000 of those. Oh, that's stupid, man. Yeah, why 10,000? 10 power 5. Is it 10,000 or it's 100,000? I guess it's 100,000. Yeah, I don't like creating like 100,000 empty vects. I guess this will work, but it's very not smart. Maybe we can create some sort of enum holder. Well, where either we'll have like a non, which will be an option. Yeah, that's. Yeah, in the end, I'll be filtering, but I want to go in reverse order because it will be already sorted. So I'll just go in reverse order from here. Because even if I filter, yeah, one trick here with maps, they do not keep the order. Yeah, actually you can set but they will not be sorted, so I just need a way to traverse. Okay, so let's keep it simple, and then we'll optimize it in a smarter way here. So I have my bucket. Then I'll do like let here will be like key and value in dictionary. What do I miss? 4. Yeah, I miss a 4. And I miss a to do here. Then I'll do can I have duplicates? No, I cannot. Okay, so yeah, let me think. So value is the count, and this will be our index. So bucket dot value as use size that push key. Okay, so this is the stage where we do have our vector sorted as a bucket. Order is set. Yeah, it's a parameter, so you can specify. You see here, if you look at the random state, there are options like you can specify different structures. But most of the time I use like random structure. I never try a different one, but in theory it should have like for some specific cases it should have like a ordered. I just need to find it. So let's see what options do we have. So random state, hash, random state is mentioned with random. It was discovered that exposing a deterministic iteration order allows a form of DOS attack to counter that incremental on the seeds on every random state creation. Okay, so some internals of Rust. Yeah, let me get back to my code here. So yeah, we do have this. Now in our bucket, we'll have everything sorted, but we'll do something like this. We'll do bucket, iterator, we'll do reverse order, we'll do filter, okay, and we do x, c, x, wherever x is not empty. We'll need items in our back. Then we do flat map. Yeah, because I need to flatten. I think it's flat map x maybe. And I'll need to take 2. And I'll need to collect the answer. Gonna build from iterator over elements of okay, so yeah, kind of we'll need to into iterator here. And okay, value push key. So let's dereference the key then. So I guess that should do it. Yeah, that should do it. Oh my god, it did work. It's a bit stupid, but it did work. So yeah, let's add a couple of other scenarios to be sure that works fine. So if we do have 1 and we need to set 1, the result should be 1. Run. Awesome. It does work. But this stuff, I don't like it. But what else can we do? What else can we do? Yeah, let me try to run it in here, see if it works or not. Yeah, I'll need to include the hash map. Moment of truth, guys. Let's run it. How did I get how did I get yeah, I guess somewhere here where I have some troubles with flattening. Yeah, let's add this scenario. Three 0 1 0 K1. 3 0 1 0 1 1 and answer being 0. Yeah, this too works. I don't need to. I feel like here somewhere the trouble is, because I'll need to flatten. Maybe I'll use flatten. And then take 2. Oh, not take 2, take K. Oh my god, I'm so... Or maybe flat map works just fine. Or flatten, maybe. I just needed to use K instead of 2. So yeah, my mistake. So instead 2, I'll need to take K as usize. Yeah, let me use this test case, add it. It did work. Let's submit. Yeah, so good news, bad news stuff. We did solve it in big O of N. So thanks to Unwarekare for the idea. Though we use ton of memory, literally. This stuff, it's insanely costly. Because we initialize the vector with the bunch of empty vectors, but at runtime I think Rust infers that they should be like I32s, and the allocation will be insanely costly. 10 power 5 free, yeah, it's 100,000. Yeah, that's correct. Yeah, let's check out the solutions. So here we have the hash map. Yeah, this is clear. Results. Sort by key. That's actually funny. This guy used the sort algorithm, and it's faster than mine, which I do not use a sort because I use this bucket structure. But the trouble here, because I need to provide this 100,000 elements, and I do this pointless 100,000 iterations. So I guess the test case is do not use like huge numbers, and my algorithm is slower than that one. Oh, hello, Dave Amanshu Rastoji. So welcome to the stream. Yeah, let's read a question. Hello, sir. A question: as a web developer, what is use of Rust? Very good question. So do you write backend or frontend? Or both? I guess both of them. I'm also a web developer, actually, but I do not write as much frontend. I do some side projects, but yeah, backend. I use Rust for every CLI tool that I plan to do. By the way, what's your language? What language do you write in? I do Node.js as a backend, and for some cases, I may use Rust to write native components, which will be called in Node.js inside. So I use Rust to optimize things for Node.js. What is this problem about? Okay, yeah, what's the problem? So, top k frequent elements. So given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. So we are given like a list of numbers. We need to count how many numbers they are. So how many ones, how many twos, how many threes, and so on. And once we have this count, we need to return the most popular, like the most popular two. So the most popular two will be 1 because it's free time, and then 2 because it will be 2 times. So what I've implemented, because it's kind of written here, we need to find something smarter than big O of n log n, which for new people, this means we are not allowed to sort. So I try to use a different approach and to sort using a different theme called bucket sort, where I'll be sorting using the index of the vector. But unfortunately, the input size is quite big. So here, I guess we may have like 10,000, 100,000 numbers. And I'll need to generate like 100,000 empty vectors, which uses quite a lot of memory. Yeah, let me hack it a little bit. Maybe I can reduce it and submit and see if they really do have test cases with 100,000. Yeah, that's funny. Actually, they do not have test cases to cover, and now I'm the first. So that's the fastest solution. So yeah, I become first because I do not use a sort, so I use just a bucket sort. But that's not a correct implementation because by requirement, we need, we may have like 100,000 items. But I just cheated, let's put it here, because I've reduced the size of the VAC and I reduced the amount of pointless operations, and then automatically the algorithm become fastest, 10 times faster, let's put it this way. Okay, so for new guys, I want to explain a bit what we're doing here. Good luck coming back. Yeah, thank you. So I switched a bit the approach. So now I'll be solving the problems in a very specific order provided by this website called leetcode.io. So he suggests a way on how to train data structures and algorithms to be logically correct, kind of. So we start first with arrays and hashing, and then we'll be moving to two-pointer problems, and then to stacks problems, to binary search, sliding window, linked list, and so on. Okay, so what should you learn? Rust or Golang? So I would not compare these two. I mean, to some extent, you can do web development in both in Rust and in Golang. Though Rust, it's way more complex. And it's a lower level language, so you can do many other things in Rust, like writing games, doing microcontrollers. So Rust is a lower level language than Go. They are not at the same level. So if you learn Rust, this is like learning a programming language which can be a door for different other jobs, not only web development. For web, Go, it's very nice idea. So if you want to just focus on web development at first, because it's okay, I suggest you to switch to Go and learn Go. It's very fast. It's still a compiled language. Compile time, it's orders of magnitude better than what Rust has at the moment. Pretty straightforward, easy language to understand. It has a garbage collector. Rust does not. Management of memory in Rust is done by the concepts at the compile time, like lifetimes, reference counters, and so on. So just start with Go at first. Maybe later on you can switch to Rust to see what this language is about, learn it, give it a shot, do a trick or two. But I'll be doing web development in future streams. I think I started the stream with presenting a tool which I really want to try. It's called the Loco. So it's inspired by Rails. I think you are new in the industry, but a couple of years ago there was a very popular language called Ruby, and it had a framework called Rails. And Ruby on Rails was extremely popular. Like many unicorn companies was using Ruby. They created like their infrastructure and so on. So I like that approach. Yeah, I mean, if we go in this direction, for sure. Yeah, Go also can be used as a low language. Yeah, but I guess it was intended for web. Personally, I will not go with a garbage collected language to write microcontrollers or devices. That would be risky. Imagine you drive a car, at some point the garbage collector decide to do a stop and do not respond in time. Highly unlikely situation, but I would not want to drive such a car. So, so I would avoid it. I would write it in C++, or any other language which I can handle the memory, and I'll be sure that I'll not have like a garbage collector time stops. Okay, I think if you have any other questions, have a scheduler. Yeah, but okay. So first, you want to learn Java with Spring Boot, but so that the popularity is decreasing. So want to choose new language like Node.js, Go. Node is good. It's a lot of tools, frameworks, and it's a very productive environment. You'll have like billions of libraries to use. Go is faster by quite a ton. So if you choose between Go and Node.js, I would choose Go. I would choose Go now, because I do write Node.js. I am a Node.js developer last 10 years. So yeah, big Go. It will not be a mistake. It's backed by Google, ton of popularity, many new projects. And this means in years there will be a need to maintain those. So, Roger. Yeah. So, okay, guys. I guess it's time to wrap up. It was a pleasant discussion. So, thank you everyone who joined. Thank you for questions. Please like, subscribe, tell your friends. More people are here. We can discuss, have fun, learn a new thing or two. That's good. So yeah, bye bye. I guess for okay, one question, sir. I know it's cultural that you start the question with sir, but I you don't need to. Uh, I'm from a European country. This it's not necessary for us. Um, so you can omit the sir part. So just you just ask question. So equal to equal relationship here. Yeah. Please ask. Which type of project it's is good to make like full stack project, not blog site, not management, something unique. Yeah, I mean, you don't need to think at this stage of unique stuff, because what you need to understand and learn it's structure, how to structure your project, how to create entities, how to create a database. So it doesn't really matter what it is about. Is it a blog or a car shop or a product shop or anything? Yeah, bye bye. What you'll need to focus it's how to structure your code, how to create models, how to create views, how to create migration, how to write all those things. So you can do a to-do list. It's at this stage it's important for you to just learn the concept of abstraction, so any project works. Once you have more experience, you can try to build something on your own, something like a startup. But at first, pick any project which may make you write a lot of code. That's important for you to understand the structure and how things are in coding, all the stages and all the steps. Sure. Yeah, this part of the stream is to help people to communicate, inspire, get inspiration, and be helpful. So that's the goal. So yeah, wish you a nice evening. I'm posting the schedule. So next stream will be on Friday. So use the bell button to receive notification, and you can catch me, ask more questions. I'll gladly answer. So have a nice evening. Bye bye.